Hello, this video is going to look at what's called the quotient rule. And the quotient rule, you'll notice, is somewhat similar to the product rule that you probably learned previously. Here we're looking at dividing two functions and how can we find the derivative if we have function f divided by function g. And it's going to be a little similar to the product rule where we're going to take the bottom function g multiplied by the derivative of the top function f minus the top function f multiplied by the derivative of the bottom function g. And all of that's going to be divided by the bottom function g squared. Or just like we did with the product rule, we can look at this in terms of u and v, but keep in mind that once again, that u and v are actually representing functions. U is just not a variable. So u is really representing a function of x, just like f of x, and v is representing a function of x. So that would be v u prime minus u v prime divided by v squared. Once again, a lot of times I like to think of this as going through the formula. V, you take the bottom multiplied by the derivative of the top minus the top multiplied by the derivative of the bottom, all divided by the bottom function squared. So if we apply that to the following example here, we have 4x cubed divided by 2x to the fifth minus 1. Then here we could certainly take and say, if we call this is u and this is v, and if we're looking for the derivative, it says that we're going to take the bottom function, 2x to the fifth minus 1, multiplied by the derivative of the top, which would be 12x squared. And you'll notice once again how I will always put each one in parentheses. So I put v in parentheses multiplied by the derivative of u. Okay. So here we have v multiplied by u prime. And then it's, be careful, minus u multiplied by v prime, and that's going to be 10x to the fourth, and all of this is divided by the denominator v squared. And there's the derivative. At this point, you're completely done with the derivative. The only thing you can do from here is to simplify the expression. And if we do that here, we could end up with, let's see, 12x squared, distribute that here, so we're going to end up with 24x to the seventh minus 12x squared minus 40x to the seventh. And I'm just going to leave this over the denominator squared. Typically here, you're not going to multiply that out. If you notice here, by multiplying the top out, we can actually combine some like terms. And here we would end up with 24x to the seventh minus 40x. That would be a negative 16x to the seventh minus 12x squared over the denominator, 2x to the fifth minus 1 squared. All right, so once again, I like to think of this as, with the quotient rule, you're taking the bottom multiplied by the derivative of the top minus the top function multiplied by the derivative of the bottom, and all of this is divided by the bottom function squared. All right, so if we look at another example here, we have f of x equals sine x divided by x. So we would have our top function u and our bottom function v. So if we want to find the derivative, it's going to be the bottom function, which is x, multiplied by the derivative of the top. And the derivative of sine x, recall that's going to be cosine x, minus our top function u sine x, and that's multiplied by the derivative of the bottom, and that would simply be 1. And I'm just going to write this in so that you can see that this is actually multiplied by 1. And all of this is divided by the denominator x squared. Now, once again, realize that here is the derivative, and from this point, all we can do is simplify the expression. And really all we can do here is on the top, we could drop out the parentheses because we know this is just simply x times the cosine of x minus sine of x all over x squared. And there's your answer. Now, you may think, well, here we could cancel this x out with 1 here, but there's nothing over here to cancel out with the sine x, so therefore we will not cancel out. So this would be your final answer. All right, we have another example I want to look at here, and we have y equals x squared plus 3x divided by 6. And I want to look at using the constant multiple rule, and then we're going to come back and look at the exact same problem using the quotient rule. So let's look at the left-hand side here. We want to use the constant multiple rule. And if we're going to do that, we probably want to rewrite this expression. And if we rewrite this, we can say, well, that's y equals, dividing by 6 here, we can think of this as being multiplied by 1 over 6 times x squared plus 3x. So now if we're using this constant multiple rule, our constant multiple is the 1/6. So now if we take the derivative, the 1/6 is just a multiplier. So we could leave the 1/6 out front. And now we take the derivative and we get 2x plus 3. And at this point, if you wanted, you could actually distribute the 1/6, and that would be perfectly fine. Or we could simplify this, and we could simply write it as 2x plus 3 over 6. And of course, you could reduce from here if you would like. We could simplify this further with the 2, the 6. Again, you could divide the 6 into both of them. And if we did that, we would end up with 2 over 6, which is 1/3 x plus 3 over 6 reduces to 1/2. Okay, so really here, any of these answers would be perfectly fine. So that's how we could look at this problem using the constant multiple rule. If we want to look at this example using the quotient rule. Now, the reason I want to look at this is because I want you to realize this expression, we really don't need to use the quotient rule. We could simply use the constant multiple rule, because what's going to happen if we use the quotient rule over here is when we go to take the derivative, remember it says we take the bottom function multiplied by the derivative of the top, which would be 2x plus 3 minus the top function, and what happens now when we multiply by the derivative of the bottom? If we multiply by the derivative of the bottom, derivative of 6 is 0. And this is all divided by the bottom squared, so that's 6 squared. And what happens now at this point when we go to simplify? Well, I'm going to leave this as 6 times 2x plus 3 minus, well, x squared plus 3x, all of that's multiplied by 0, so that all cancels out. And this is all divided by 6 squared. And you could leave it as 6 squared, or we could square it to 36. And we'll notice then 6 goes into 6 once, 6 into 36 is 6 times, and you'll realize we're left with 1 over 6 times 2x plus 3. Or once again, you could write it as 2x plus 3 over 6, or 1/3 x plus 1/2. And you can see here, it doesn't matter which one we use, whether we use the constant multiple rule or the quotient rule. I think you'll find the constant multiple rule to be much easier and faster for this problem. And I will point out, even at this point here, for example, where we have rewriting the problem as y equals 1/6 times x squared plus 3x, you don't have to leave the 1/6 on the outside. We could continue to rewrite this and actually distribute the 1/6, and we would end up with 1/6 times x squared plus 3 over 6, which would be 1/2 x. So you could distribute the 1/6 first and then take the derivative, and you would get 2 over 6, which would be, well, I'll just write it as 2/6x plus 1/2, and realize we get 1/3 x plus 1/2. So you could also work it out this way as well. So once again, if we go up here to review, with the quotient rule, you're looking at dividing two functions here. U divided by V, you simply take the bottom function multiplied by the derivative of the top, and make sure you do this correctly because it's subtracting, and if you switch the order, it's going to give you the wrong answer. So it's the bottom times the derivative of the top minus the top function multiplied by the derivative of the bottom, all divided by the bottom function squared.